Hello, good afternoon. Welcome to Advanced Tutorial class. Today we'll be continuing from matrices. We have studied matrices in the past previous classes, and today we'll be moving into determinant of a matrix. You can remember in our last classes, the first class we had basic operations of matrices, that's addition, subtraction, and multiplication, that's scalar multiplication. Then in our second class we had multiplication of matrices, basically 2 by 2 matrices. So today we'll be moving into the determinant of a matrix. Now this part is technically more interesting than what we've been doing previously. You just have to learn the intricacies and you'll be good to go. This is what we have. Now I represent the matrix by this sign, usually known as delta, like a little triangle, delta. So delta equals A, B, C, D. Now we have the matrix. But anytime you are looking for the matrix and determinant of the matrix, instead of you to have your normal closed parenthesis, you're going to be having straight columns that encloses the elements of the matrix. Now, for instance, you have to find the matrix that has its elements A, B, C, D arranged in this manner. You end up having this. This is how it goes: A times D minus B times C. This times this, and this times this. So they move diagonally. So you'll be having AD minus BC. So such is the way of finding the determinant of a 2 by 2 matrix. So before we move on to 3 by 3 matrix, we'll be looking at basic examples under this. For example, let's have an example. Example 1. Find the determinant of the matrix A equals 3, 0, 2, 5. 3, 0, 2, 5. So to find the determinants of A, you'll be having A itself this way. You can see I put A in straight line columns and close it. Then I'll be having all the elements of A in those straight line columns: 3, 2, 0, and 5. So using our basic example that has been listed up here, it becomes 3 times 5 minus 2 times 0. 3 times 5, that's 15. Minus 2 times 0 is 0. So 15 minus 0 is 15. So determinant A is equal to 15. I believe you agree with me that this is actually quite simple than you envisaged. But let's go on with more concrete examples. If you actually look at it like that, we'll be using negative elements. So another matrix, let's say B equals minus 4, 8, 2, and 10. We have this, and now you have to find determinant of B. So I have B in enclosed columns. So minus 4, 8, 2, and 10. It's elements in enclosed columns. So I have this minus 4 times 10 minus this multiply by that's 2 times 8. And that way you'd like to put it. So that becomes 4 minus 4 times 10 is minus 40. Then 2 times 8 is 16. So you're having minus 16 all together. So bringing this minus 40 minus 16 gives you a total of minus 56. So that is value for the determinant of B. So we're moving ahead to 3 by 3 matrix, where we'll look at something even more interesting. So we're moving into this determinant of a 3 by 3 matrix. Now, there's something you have to understand here. When we had the 2 by 3 matrix, it was just quite easy when you multiply the diagonals and then subtract. When you have a 3 by 3 matrix, such as this: A, B, C, D, E, F, G, H, I. Don't be scared, we're not doing alphabets here. It's just an illustration. You see, there is something that helps you here, and that is known as cofactors. Now, each element here has a particular factor, that's a particular sign, either plus or minus, that is attached to it when you are going to use it in finding the determinant. This is how it goes. For example, it could be in this way. Now, there are 3 major possibilities for this. You could have it plus, minus, plus, minus, plus, minus, plus, minus, plus. They alternate, meaning that when you have plus for the first one, minus for the next, plus, minus, plus, minus, plus, minus, and what? Plus. They alternate. You can also have it in this way: minus, plus, minus, plus, minus, plus, minus, plus, minus. So you can see alternation of the signs of negative and positive signs as the cofactors of this. So what this means, if I'm to use this now, this will be the sign beside it. Then I'll pick this. Now let me show you. If I'm to make this now using this one, let's assume I'm using this one as my basic cofactors. I'm erasing this one and to use this one as the templates for my cofactors. So this is how it goes. With every member you take, you rule out the size of that. That's, you rule this out, the row, and you rule the column out. So if I'm taking A, for instance, so I'll rule this space out and rule this space out. So I'll be having this here. E, F, H, I as the sub factors under here. Then the next one, remember this is plus, minus, plus. I'm using this one's up. Plus, minus, and what? Plus. So for the next member, which is B, so that B will be coming because of the fact that it's minus on this, we'll be having a minus B. Then rule this space out and rule this space out. I'll be having the ones here. D, F, G, I. D, F, G, I. Over here. So the next one is C. That will be a plus C. Into, so I rule this place out and rule this place out. So I'll be having D, E, and G, H. D, E, G, H. So obviously, as you could guess, you solve this 2 by 2 determinant just the way we have done the other ones, and then you're just good to go. Okay, so we have an example for our 3 by 3 matrix. So we find the determinant of C having this element 2, 0, 3, minus 1, 4, 5, 6, 7, and minus 2. So to go ahead to find the determinant of C, so I have this C equals 2, 0, 3, minus 1, 4, 5, 6, 7, and minus 2. So that's the way I've explained the cofactors. So I'll be using this plus, minus, plus, using the top members of this. So I'll be having 2. So when I have 2, I'll be this place and this place will be off. So we'll be having 4, 5, 7, and minus 2. 4, 5, 7, and minus 2 for the first one. So the next one is 0. That's because we're having minus here. So minus 0 into, so taking this side and this side off, we'll be having minus 1, 5, 6, and minus 2. Okay. Lastly, we'll take 3. Now we plus 3 into, so taking this 3, we take this side off, take this side off. I'll be having minus 1, 4, 6, and 7. Minus 1, 4, 6, and 7. So from here we proceed to solve just the way we solve 2 by 2 matrices. So I'll be having 2 into 4 times minus 2 minus 5 times 7 minus 0 into minus 1 times minus 2 minus 5 times 6. Lastly, plus 3 into minus 1 times 7 minus 1 times 7 minus, so we have minus 1 times 7 minus 4 times 6. Now you notice I put most of these ones in another bracket. That's because I didn't want the conflict of the signs here. So having laid this down, we now move ahead to solve them. So we have 2 into, so 4 times minus 2 is minus 8. Then 5 times 7 is 35. So you have minus 8 minus 35. Close brackets. Minus 0 into minus 1 times minus 2, that is 2. Minus 5 times 6, that's entirety. Then lastly we have plus 3 into minus 1 times 7 is minus 7 minus 4 times 6, that is 24. So having laid this down. Okay, so we have this now and we'll proceed to solve again. So that's 2 into minus 8 minus 35, that gives us minus 43. Then minus 0 into 2 minus 30, that is minus 28. Plus 3 into minus 7 minus 24, that is minus 31. So all we have to do now is to open these brackets. So 2 times minus 43, that is minus 86. Then minus 0 times minus 28, so that is plus 0. Okay? 0 times anything is 0, isn't it? So you have plus 3 times minus 31, that will be giving you minus 93. One last step to our final answer. Minus 86 plus 0 minus 93. Now this 0 is nothing, so we have made minus 86 minus 93. To get this answer, just add them up together, but at the end you put a negative sign to it. So I have a minus sign here already. So 3 plus 6, that's 9. Then 9 plus 8, that is 17. So my answer is minus 179. So that is the determinant of C. If you have something that you are not very clear with, feel free to drop your questions in the comment section, and feel free to like and subscribe to the page. Thank you. See you in the next video.